So you might have heard the word object-oriented programming come around a few times and how Java is an object-oriented language. So let's try and think of what object-oriented programming means. Well, essentially, everything in Java is just an object. It's a way we can organize our code around objects and their interactions. So today we're going to cover the most basic concepts of object-oriented programming, what a class is, what an object is, and in the next video, we'll dive into the details of what makes it so special. So a class is basically a blueprint or a template that defines the properties, data, and behaviors, or even methods that objects of that type will have. We already covered what methods were in the last video, so if you need a recap or haven't watched it yet, go ahead and do that now. So the key elements of a class are instance variables, methods, and constructors. Instance variables are just like regular variables that we know hold the state or attributes of an object. Methods, as we know, are functions that define what an object should do. And the constructor is just a special method to create and initialize objects. So in the example below, we'll see a few things we haven't seen before. We'll first see public class person. This here is essentially saying we want to make a public class so that anyone or anything can access it. We want it to be a class. And we're going to make it the name of the class person, just like we're naming a variable, except it starts with an uppercase letter. Then we're defining two instance variables, name and age. However, you're going to notice that we don't assign any value to them, and they're left empty. This is because below those two variables have a constructor. In that constructor, we're taking two parameters, name and age, which have the same type and name as our instance variables. And in that constructor method, we're saying this.name is equal to name, and this.age is equal to age. You'll notice that Java also knows this is a constructor because the exact same name as what we made our class named. So what does this mean by this.name is equal to name? Well, by using the keyword this, we're saying we want this class, and in this class, we're going to get the variable name, which is our instance variable, and assign that to our parameter called name, and we'll do the same thing for age. Below the constructor, we have just a simple method saying void say hello, and it prints out my name is plus name. So this class person almost acts like a blueprint. It tells us that every person object is going to have a name and age and can perform the action of saying hello. An object is an instance of a class. It's the actual item that's created using the class blueprint. So for every person, we'll have an object. So if the class is maybe a recipe for a cake, the actual object is the cake you're baking. So if we look at the example below, we'll see a few things here. The first one being inside our main method, we're creating a variable, but it's nothing like we've seen before. Essentially, all it's doing is making a variable with the type of person, or a class name, and we're assigning that variable to the name of person1, so we could also make another variable there called person2, and then we're assigning that variable to a new person, and inside of that person, we're defining the parameters of Alex and 23 for the name and age. Then we're just using that person1 object and using our method we defined earlier, say hello. So we could also create 2 or even 3 other persons and just use say hello there, and we don't have to create all that other boilerplate code. When we create person1, we're essentially just making an object using a blueprint defined by person. So there's state and behavior. So the state in here is the data actually held by that object. For example, the name and age. The behavior would just be the actions that the object can perform. For example, saying hello. So a class just encapsulates both the state and the behavior, meaning it can hold both the data about an object and the operations you can perform in that data. So let's just go ahead and go into IntelliJ and see how we can use classes and objects. So I'm in IntelliJ here. Let's maybe use a car example. So in our source main, Java asnos, or whatever your last package here that main is in, we're going to right click it, go a new Java class, and we're going to say maybe car. Inside of that, we're going to select class and hit enter. Inside of here, we're going to say integer max speed. Remember, we're not assigning it to anything. Maybe a string of brand. And let's do an int of year. So I'm actually going to reorganize these, I think. There we go. So let's go ahead and make our constructor. It's going to be car, the same exact name as our public class car. We're going to have to define string brand, int year, and int max speed. Open curly braces, and we'll say this.brand is equal to brand, semicolon. This.year is equal to year, and this.max speed is equal to max speed. So this can get pretty confusing, but just think this, so this class, that means in that class, we're going to access brand, and then we're going to assign that to the parameter brand here. So this.year, guess which one that is? That's right, it's the one up here. So let's make a special method for this too. I'm going to say maybe void, or actually I'm going to make this an integer, get max speed, and we'll just return max speed. So I'm in our main class here, and let's maybe say car Mustang is equal to new car Alright, so if you want to see the parameters of any method or class, you can just hit Control P or Command P. So the brand, I'm going to make Ford. The year, maybe 1981. And the max speed, 210 for sure. Then we can just say Mustang dot get max speed. And let's actually print this out. So system dot out dot print line Mustang dot get max speed. And so now, if we run our code, we're going to see 210 because that's the max speed defined here. We could change this to maybe 270, and there we go. So we could also just say Mustang dot max speed here because these variables are currently public. We're going to get into access modifiers soon, but this is really nice because what if we wanted to make other cars? So maybe a car motorcycle is equal to new car. And let's do Honda, I don't know, in 2007, this maybe do 180 miles an hour. And let's make another car, we could do a Tesla, sure. It's equal to a new car, Tesla. And then maybe the year is 2021, and the max speed is 240. Alright, and now maybe let's make a for loop that's going to iterate through all of them. So to do that, we're going to make an array. So a car array, actually, let's make a list. Sure, let's make a list. So let's make a list of type car is equal to a new list here. Or a new array list, sorry. That doesn't need anything in it. Let's make the list called cars. And now let's say cars.add. Let's copy this. There we go. That's a semicolon here. And let's just copy this down. So cars.add the Honda. Alright, and now let's do that one more time for cars.add. There we go. Just so we can add it to a nice list. Alright, so you're going to notice we don't actually need to define a variable here of the car Mustang or the car motorcycle, just because that's being stored in here. So all we need in here is the new car. So now let's maybe say for car, out of cars. So the car being our class here. The car just being what we're naming the variable that we want to access. And out of cars is our list here. So let's maybe say system.out.println or print line. Let's do car info. Then we'll say car brand and then plus car dot brand. We're going to copy this down. Car year and car max speed. I'll just remove car here, so max speed. So year and max speed. I'm going to add a new line after this actually, just so it can be a little bit more clean. And so now if you run this, we're going to see car info, car brand Ford, car year 1981, max speed 270, and we're going to see that for all of the other classes. So in the last video we talked about what access modifiers are briefly, but what actually are they? Well, we have three main access modifiers available to use: public, protected, and private. Public is the default one. It means we can access it from anywhere, like in our person class. Even though we didn't say public void say hello, if we didn't put anything before the type of the method or variable, Java's just going to assume it's meant to be public. But sometimes we want to have methods in our code that aren't visible to the outside world, whether these be helper functions or code the end user just shouldn't be allowed to modify. For that, we can either make the method protected or private. So protected just means that you can still modify it as long as you're modifying it from the same package or folder that's in. And private just means you can't access it from anywhere except in the class you're currently in. So if we look at the three examples below, we have three functions. We have our public void say hello, which we all know and love, which we should be able to call from anywhere. We'd only be able to call say goodbye if we were either in the same package or subclasses, and for our private and do math, we would only be able to access that in our class person and wouldn't be able to call that from anywhere else. So here's your challenge for this video. I want you to make a banking system. This one's going to be a bit challenging, but I believe in you. I want you to make a very simple bank account system. You're going to create a bank account class to simulate multiple bank accounts associated with different names, where you can deposit, withdraw, transfer, and check your balance. So for example, We create a bank account for Alex with an initial balance of $500. We can transfer $100 over to Bob and $40 from Bob to Steve. I'm going to keep it somewhat vague to try and make you think outside the box, but if you'd like an extra challenge, make it so users can transfer money all through the command line instead of printing the balances out at the end. I'm going to give you a few seconds to pause the video before I move on to the solution. Alright, so I've implemented the banking system. Let's go over what we're doing. So in our public static void main, I'm making a map of string and user. String being the username, and the user being this user class I made. In this user class, we have a private string name and a private bank account. I'm making these private because I don't think we should be able to modify their name or their account. So when we initialize the user, I'm setting the name to name and the account to a new bank account. I'm also making two methods, getName and getAccount, just because while we don't want to modify these, we still need to get the values from them. Now, in this bank account, I am making a private double balance, again, because we shouldn't really be changing the balance, and I'm making a public bank account, our constructor, and setting the balance to the initial balance. I made a deposit method, which is taking an amount. If the amount is greater than 0, we're going to say balance plus equals amount. Then we're going to print out we deposited this amount. Else, the amount must be positive, because, the amount has to be positive. You shouldn't be depositing negative money. That could be pretty bad. We then have another function called withdraw. So if the amount is greater than or equal to 0, and they have more money in their balance than the amount they're trying to withdraw, let's minus the amount from their balance and just say they withdrew the money. Else, they have insufficient funds. Notice we made this a boolean, and we're returning true if it was successful or false if it wasn't. Because in this transfer to, if this dot withdraw amount, so if it went fine, we're going to say let's deposit the amount into the other bank account here. And we're going to say we transferred the money. Again, we're going to return true or false. Then I'm just making another function called getBalance. And now in our main function, we're defining a scanner here to accept user input. We're putting Bob, Steve, and Alex into our users map. Then we're just going to print out some steps the user should take. Welcome to the Bank of Asnos. You should subscribe. That's a pretty nice print line here. And then while true, because we want this to go forever, let's enter the command. We're going to get the command from the scanner.next line. Then we're going to split that command into parts per each word, and we're going to split it by a space. So if the part's 0, since indexes start at 0, not 1, if that equals the ignore case of transfer, so the first one is transfer, and the parts.length is equal to 4, because we need 4 arguments here. We need the transfer, the from user, to user, and the amount. So we're going to get the from user, which is the index of 1, from user. We're going to get a to user, which is the second argument. Then we're going to get a double amount, and we're going to parse the double of parts 3. If the users contains the key of from user, so let's say they enter Bob, we have to make sure Bob actually exists in our users and they didn't try to put something like Jeff in there. So if that's true, and a users contains the to user, we're going to get both of them and get the user class from them. Then for the sender, we're going to transfer the money to the receiver, else we're going to print out invalid user. Down here is basically the same, so if part 0, the first word, equals balance, and part length equals 2, because we need the user we want to see the balance of. So let's get the user, let's print out their balance, else it's an invalid user, or it's an invalid command. So let's see this working in action. Case sensitivity is pretty important here, so let's look at the balance of Bob. Bob has $1,000, he's pretty rich. Let's look at the balance of Alex. Alright, and the balance of Steve. So maybe let's transfer from Bob to Steve, maybe $140. Alright, so withdrew 140, deposited 140, and transferred 140. So now if we do balance Bob, oh, sorry, case sensitivity, he only has $680. But if you view the balance of Steve, he has $640. So I really hope you were able to get that. If you had any trouble or stuck, you can either try asking me in the comments or try and view part 5 to solve errors on your own. In the next video, we're going to talk more about object-oriented programming, and that's going to be the last video of our Java crash course before we start to make our client. I'll see you then.